Let's look at absolute value equations and inequalities. What is an absolute value? Well, the absolute value of a number is the distance that number is away from zero. So, absolute value is the distance a number is from zero. And it should always be positive because distance is always positive, whether you go towards the negative numbers or the positive numbers. Distance should always be positive. For example, if we look at the number line, at the numbers -5 and 5, those two numbers are 5 units away from 0. So distance-wise, they're both 5 away from 0. So that means the absolute value of -5 is 5, and the absolute value of 5 is also 5. So the absolute value of any number should be always equal to the positive of that number. Now, what are the steps to solving absolute value equations? Well, step 1 is to always isolate the absolute value on one end. Step 2 is once the absolute value is isolated, identify what the absolute value is set equal to. That is, what is the number after the equal sign? Well, if that number is a negative number, then since absolute value or the distance cannot be equal to a negative number, it has no solution. One example of that would be if you have an absolute value of 2x plus 5 equals -4, it doesn't matter what x value you try to choose, you will not be able to satisfy this equation right here, right? You can put in whatever x value that you want here. This is always going to turn out to be positive. The smallest this could be is 0, and 0 is not equal to a negative number. So this cannot be equal to a negative number. Now, part B is that, well, what if it's equal to 0? Well, if it's equal to 0, it has a solution. What you do is you take the stuff inside the or the absolute value and you set it equal to 0 and then solve for the variable. Let's look at an example. So suppose we have an absolute value of x plus 5 is equal to 0. So based on this, it says set what's inside the absolute value, well in this case the x plus 5, equal to 0. So we have to say x plus 5 is equal to 0, and then you solve for x. That is, get x alone. So to get x alone, you would subtract 5 on both ends. That will give you the one solution, which is x equals -5, meaning the only x value, or the only value of x that would satisfy this equation is if x equals -5. You can double check. Plug in -5 here. -5 plus 5 is 0, absolute value of 0, and then you would have a 0 equals 0. The third condition is that what if the absolute value is set equal to a positive number? Well, if it's equal to a positive number, there's always going to be two solutions. And we do the same thing as what we did here. You take what's inside the absolute value, you set it equal to the positive of that number, and then you take what's inside the absolute value, you also set it equal to the negative of that number. And then you solve for x. Well, if I solve the left-hand side for x, divide both sides by 3, excuse me, x equals -2. And then if I divide the other side by 3, I get x equals +2. So as long as the absolute value is equal to a positive number, there should be two solutions. Step 3 is to check your solution always. Let's look at some example. So let's say I want to solve this equation here. According to step 1, it says to isolate the absolute value. Well, as you can see here, the absolute value is already isolated, right? Step 2, if it's equal to a positive number, make two equations. Take what's inside the absolute value, set it equal to the negative of this number, which is -5, or you take what's inside the absolute value and you set it equal to the positive of that number. And then you solve for x. So if I look at this right here, I would subtract the 3 first. That will give me 2x equals -8. And since 2 is being multiplied to the x, inverse of multiplication is division, so divide both sides by 2. you get a solution x equals -4. Now over here, we're going to subtract the 3 on both ends. We're going to get 2x equals 2. Same thing, divide by 2. You get x equals 1. Now I have to check. Step 3 says to check. So in order to check, what you do is you take what your x value is equal to. So if I take -4 and substitute right here, 2 times -4 is -8. And -8 plus 3 is -5. Well, absolute value of -5 is 5, and then you would have 5 equals 5. That works. What if I plug in 1? Well, 2 times 1 is 2, plus 3 is 5. Absolute value of 5 would also be equal to 5, so that works as well. So the solution to this problem is going to be x equals -4 and x equals +1. What if I have this equation? Well, in this case, we're going to have to follow through the steps. Let's isolate the absolute value. As you can see, the absolute value is not isolated because of the +8. So the first thing we have to do is get rid of this 8. So we're going to subtract 8 on both ends, and then you get absolute value of 1 minus 4x equals 5. Now, step 2 says that once the absolute value is isolated, what is it set equal to? If it's equal to a positive number, you're going to make 2 equations out of this. One of them would be what's inside the absolute value equal to the negative of that number, or what's inside the absolute value equal to that number. And then you solve symbolically for x. Subtract 1, subtract 1. -4x equals -6. Divide both sides by a -4 to isolate the variable x. X equals +6/4, which is the same thing as 3/2. On the other side, we can subtract 1 on both ends. You get -4x equals 4. Divide by -4. X equals -1. Double check. Take the values and plug them in. And if you plug them in, I guess I can plug in 3/2 here. Well, -4 times 3 is -12, divided by 2 is -6, and 1 minus 6 is -5. An absolute value of -5 is +5. 5 plus 8 makes 13, which is what I have here. Take the -1. If I plug a -1 here, -1 times -4, this becomes +4, plus 1 is 5. Absolute value of 5 is 5, and 5 plus 8 is 13, which is what we have. So both those values satisfy the equation, and therefore those are the correct solutions. Example 3, the absolute value is isolated, and it's equal to a negative number. Well, remember, distance is equal to negative. That does not make sense. So according to that 2a, step 2a, this has no solution because it's set equal to a negative number. And example 4, we have this following equation here. So this is not isolated, so step 1, let's isolate the absolute value. So let's subtract 5 on both ends because 5 is being added to this. Let's take away the 5 by subtracting. And we're left with absolute value of 4x on the left-hand side equal to 0. Well, if it's equal to 0, there's going to be one answer. So take what's inside the absolute value and set it equal to 0. And solve for x. Divide by 4. Divide by 4. You get x equals 0. Let's check. If I plug in 0 here, 4 times 0 is 0. Absolute value of 0 is 0, and 0 plus 5 is 5, which works. Over here, let's do step 1. Let's isolate the absolute value. So first thing we're going to do is take away of this 3. So we're going to subtract 3 on both ends. And let's get rid of this 2. Remember, we cannot distribute this. So we have to divide by 2. So if you divide by 2, you get absolute value of x minus 2 is equal to positive 4. Well, since the absolute value is set equal to a positive number, make 2 equations out of this. What's inside the absolute value equal to the negative 4, or what's inside the absolute value equal to the positive 4. And solve for x. Plus 2 plus 2, x equals negative 2, plus 2 plus 2, x equals 6. And check. If you check them, they both should work. The next one is, well, what if you have absolute value equal to another absolute value? Well, it works the same way. In this case, what you're going to do is you're going to take what's inside the absolute value here and then set it equal to the negative of that here. And then also take this, set it equal to the positive of that, as you can see. The other way should work as well. You can take the 2x minus 3 equal to the negative of this, and then 2x minus 3 equal to the positive of that. They should both give you the same answer. Okay, so what we're going to do is we're going to distribute this negative symbol. Negative means negative 1, so negative 1 times 2x would be a negative 2x, and negative 1 times negative 3 is positive 3. So on that side, you should get this. Now we're going to move the variable terms to the same side. I'd probably add the 2x over to this side and move the 5 over to the other side. So I'll subtract the 5. X equals negative 2x minus 2. And then we're going to add the 2x over to get 3x equals negative 2. The last step, because we're multiplying here, we have to divide by 3. So if we divide by 3, you get x equals negative 2/3. Let's do the same here. Add 3, x plus 8 equals 2x. Move the x to the same side. So we're going to subtract the 3, subtract the 3. You get 8 equals x. Check. You can plug them in and make sure they satisfy. Let's check the 8. If I plug in 8, 8 plus 5 is 13. Absolute value of 13 is 13. If I plug in 8 here, 8 times 2 is 16, and 16 minus 3 is 13. Absolute value of 13 is 13, which makes both sides equal. And when you plug this in, you should get the same answers as well. So that works, and this works. The next one we want to look at is interval notation, which is used to write solutions when you're dealing with inequalities. So we're going to look at the difference between parentheses and brackets. Brackets are used when the endpoint of those numbers is part of the solution, where parentheses says that the endpoints are not part of the solution. And this would make more sense when we look at an example. So the main concept here is that parentheses represent solutions that are greater than or less than the number, right? And brackets start at those numbers, right? Greater than or equal to or less than or equal to, basically. So what we're going to use is we're going to use bracket whenever you have this symbol right here. It's either less than or equal to or greater than or equal to. And then parentheses would be used when you have symbols that are less than or greater than the number. Here's an example. So this one says that the solution, or the x values that we're interested in, is less than 5 and bigger than negative 5. It does not say it's equal to 5. It says less than 5 and bigger than negative 5, where in this case, the numbers negative 6 and positive 5 are not part of the solution, right? And we're going to use parentheses because it says use parentheses when you have less than or greater than symbol. And we do have the less than symbol here. So that means to write the solution in interval notation, I would have to use the parentheses around those endpoints. And again, Having a parenthesis around those numbers means the numbers -6 and 5 are not part of the solution, but every number between them is part of the solution. Second example, we have x is greater than or equal to 2, but then less than 9. And in this case, well, x is less than 9. Well, it could be anything that's less than 9, and it has to be greater than or equal to +2. Well, what does it really mean? Well, this one says x is greater than or equal to 2. It could be 2 or anything above. And then over here, it says x has to be less than 9. So the difference here is that we're going to use a bracket around the 2 because it falls in this category here. Anything that has a less than or equal to or greater than or equal to, you have to use a bracket around that number. And then, of course, when you see a less than or greater than, use parentheses around the number. So bracket around the 2 and parentheses around the 9. And again, this means 2 is part of the solution, because x could be greater than or equal to the number 2. Over here, x has to be less than 9. It cannot be 9, right? That's why we have the parentheses, meaning 9 is not part of the solution in this case. So the type of absolute value inequalities, we have two main types of absolute value inequalities based on the comparison sign. Case 1 is when you have an absolute value less than or equal to, or it could be just less than, strictly. And this is what it looks like. If you have an absolute value isolated on one side, and then you have the symbol less than or equal to this positive number b, or the absolute value less than b, where b, the capital B is just a positive number. B has to be a positive number. And then case number 2 is very similar. The only difference is the symbol. What if the symbol flips over into greater than or equal to, and then greater than b? Those are the two cases that we're going to look at. Look at case 1. Case 1 is that if you have an absolute value isolated on one side and followed by the symbol less than or equal to, or strictly less than b, where b is a positive number, then the expression inside the absolute value must be between the negative and the positive value of that number. Steps to solving this absolute value inequality, for example, this is what it looks like. So you rewrite as a compound inequality, right? You take what's inside the absolute value. It must be less than or equal to the positive, or greater than or equal to the negative of that number, negative of that b. And then you solve for x. And then if you have a less than symbol, it works the same way. Just make sure you have the same symbol here. And then you solve for x. Case 2 is that what if you have a greater than or equal to symbol, or a strictly greater than symbol? Then what we do is the expression inside the absolute value in this case must be either greater than b or less than negative b. And here's what it looks like. So what you do is that once you isolate the absolute value, if it has the symbol greater than or equal to, and then you have a positive number, then what you do is you break it down into two inequalities. The expression inside the absolute value is less than or equal to that negative of that number, or what's inside the absolute value is greater than or equal to that b. And then you solve each inequality for x and then combine the solutions together. And then it should work the same way for this as well. If you only have the greater than symbol, the only difference is the symbols right here, right? Well, this one doesn't have the equal symbol underneath. So let's look at an example. Let's say we want to solve this inequality here for x. So the first step is to isolate the absolute value. And to do that, take every number that's outside of the absolute value over to the other side. So I have a plus 1 here. To make it disappear, I have to undo this. To undo it, you always do the inverse operation. So since you have a plus 1 here, you have to subtract 1 on both ends, which simplifies into this right here. And this is where you make the decision. Do you have case 1 or case 2? Well, since this has the less than or equal to symbol, I have to look for that symbol in one of those two cases. And I believe case 1 is the one that has the less than symbol, which states that if you have an absolute value of ax plus b is less than or equal to b, then the expression inside the absolute value will be less than or equal to the positive or greater than or equal to the negative of that number. So using this case right here, we can say that 2x plus 4 must be less than or equal to 3 or greater than or equal to negative 3. As you can see here, we drop the absolute value because that's what it says here. And then we can go ahead and solve for x. So let's subtract 4 on all the sides. You get a negative 7 is less than or equal to 2x, and it's less than or equal to negative 1. To isolate the variable x, we have to divide by 2. So if we divide by 2, you get negative 7 halves is less than or equal to x, less than or equal to negative 1 half, or it could be written as a decimal as well. Negative 3.5, less than or equal to x, and it's less than or equal to negative 0.5. Now, if I were to graph the solution set, right, then I would put a dot at negative 3.5 and negative 0.5, right? Those are the two numbers that we have here. Now, the solution is everything between those 2 points as well as including those 2 points, right? So that means everything within this 2 points should be shaded, because the value is between those two numbers and including those endpoints. And this is the graphical solution. So the solution using interval notation. Now, the interval notation is using brackets and parentheses. Well, if you remember from that previous couple slides ago, brackets are used when you have the less than or equal to or greater than or equal to symbol. In this case, we do have the less than or equal to symbol, so that means we're going to have to use a bracket around the endpoints. All right, let's look at this example here. We want to solve the inequality. Absolute value of 2x minus 5 is bigger than 3. Well, what you notice here is that the absolute value is already isolated, right? So step 1 is already done. Once you isolate the absolute value, you kind of have to decide whether you have case 1 or case 2 type. Well, let's look at the symbol. The symbol says bigger than 3, and that is the case number 2. So we have to apply case number 2. Well, what does it say? Case 2 says if you have an absolute value isolated on one side with a bigger than symbol, and this number is positive, which is what we have, then you can make two different inequalities out of this, right? You take what's inside the expression and you make it less than the negative of that number, or you take what's inside the absolute value, make it bigger, and use that number, same number 3. So in this case, it would be 2x minus 5 is less than negative 3, or 2x minus 5 is bigger than 3. And then you solve each inequality one by one. So let's add 5, which simplifies 2x is less than 2. And then we can divide by 2 to isolate the variable x. So you end up with x is less than 1. Or we can add 5 to both ends. You get 2x is bigger than 8. And then again, let's divide by 2, which simplifies into x is bigger than 4, right? So what we get out of this is that the solutions to this inequality would be everything to the left of 1 and everything to the right of 1 together. In a number line, we can graph them. So as you notice here, 1 is not part of the solution as well as 4, right? But everything less than 1 and everything more than 4 are a solution. Therefore, we're going to put an open circle around 1 and 4. So if I put a circle here and everything to the left gets shaded, and then I can do the same on the other end. Put a circle around that 4, meaning that 1 and 4 are not part of the solution, but everything to the right and everything to the left of this would be a solution. Now, in interval notation, using parentheses and brackets, we have, as you can see here, we have two different inequalities, right? One is going to the left, the other is going to the right. So for this side here, the smallest number that we tend to use is negative infinity, and then it goes all the way to 1. And then for here, it's 4 all the way to infinity. So as you can see here, that would be the inequality symbol. And this U symbol right here is basically means or. So it's this or this. They should both work as a solution. Example 3, we're going to isolate the absolute value first. So let's add 7 to both ends, which simplifies into this. And then the next part would be to get rid of the 4. Well, since 4 is being multiplied to the absolute value, we can divide by 4. Of course, if you divide both sides by 4, you would end up with this inequality here. Now, once you isolate it, then look at the cases that you have. Less than symbol or less than or equal to is going to be the case 1. So in this case, that's what we have. And according to case 1, we can take what's inside the expression, inside the absolute value, make it less than b and greater than negative b. Well, we can take this x plus 3 and make it less than 4 and greater than negative 4. And then to solve for x, you would just subtract 3 on all the sides. You get negative 7 is less than x, and it's less than 1. This would be a solution, meaning x could be any number between negative 7 and 1. And then, of course, using the interval notation, it would be from negative 7 to 1 with open parentheses on both ends. Now, the graphical solution for this would be, since negative 7 and 1 are not part of the solutions, we're going to have an open circle around negative 7 and 1, and then everything between should be shaded. Example 4. Let's go ahead and isolate the absolute value here. So first, we're going to take care of the 4 by subtracting 4. And then you'll be left with negative absolute value of x plus 2 is greater than or equal to negative 12. And then we still have a negative here. Now remember, a negative means it's a negative 1 outside here. So to get rid of that, we have to divide by a negative 1, since this negative symbol is being multiplied to this. Inverse of multiplication is division. So let's divide by a negative 1. And then you have absolute value of x plus 2. Remember, when you divide or multiply by a negative number, the symbol is going to switch over. Right? Every time you divide or multiply, you have to reverse the symbol. And then negative divided by negative is positive. Now this is a less than or equal to symbol. That's case number 1. And according to that, we can take the expression inside the absolute value and make it less than the positive and bigger than the negative of that number. So we can take x plus 2, make it less than or equal to 12, and bigger than or equal to negative 12 in this case. To solve for x, we're going to subtract on all the sides 2. And then you get a negative 14 is less than or equal to x, and it's less than or equal to 10. So that means our solution could be anything between negative 4 and 10, including the numbers 10 and negative 14. Interval notation, whenever you have the less than or equal to symbol, you have to use a bracket. So we're going to use a bracket around those endpoints, and that's what we see here. And then this next example here is similar to what we just did. We're going to subtract the 5 to isolate the absolute value, which simplifies into that. Let's get rid of this negative 3. Well, since it's been multiplied, we have to divide by a negative 3. Again, the negative 3 and negative 3 is going to cancel out. You have the absolute value of x minus 4. And because I divided by a negative 3, we're going to reverse the symbol. Now what this says is that it's greater than or equal to, which is case number 2. Well, what does case number 2 say? Well, if you have the greater than symbol, or greater than or equal to, then you can make two different inequalities out of this. One is what's inside the absolute value must be less than or equal to the negative of that number, or this bigger than this. And then solve for x, just add 4. You get x is less than or equal to negative 5/3. If you combine those two, if you're using a calculator, make sure you put the fraction in parentheses and then add the 4 at the end. So that should be able to get you this. And then we can do the same on the other end. We can add 4 to both ends, and that will simplify into x is greater than or equal to 29/3. So a solution for this problem is x is less than or equal to negative 5/3, or x is greater than or equal to 29/3. So any number that's less than or equal to this, or greater than or equal to this, should be a solution to this problem. Here are two absolute value inequalities, one with no solution and one with all real solution. Let's look at the one with no solution. So if we look at this inequality right here, if you notice here, this side is a negative, and that's where the problem starts. If this side is a negative, then you cannot apply that case 1 or case 2 that we talked about. That only works for the positive values here. So what happens if this is negative? Well, remember, absolute value is the distance a number is away from 0. And distance is always positive, or the smallest it could be is 0. So that means the smallest this could possibly be is 0. And if I compare 0 with this number, 0 is less than negative 5 is what I get, which is not true. And therefore, this one has no solution in this case. You cannot come up with an x value that would satisfy this condition. You can try any x value. You can try to plug them in here. This side is always going to be bigger than this side. It will not be less than a negative number. And here's the explanation basically. The absolute value of any expression is always non-negative, meaning it could be 0 or positive. Therefore, it can never be less than a negative number like negative 5 in this case. So the inequality has no solution. What about an absolute value inequality with all real solutions? Well, again, if we look at the case where this side is negative, and then we flip the symbol, right? The absolute value of x is more than or equal to negative 2. And again, since this is negative, I'm going to compare this number with the smallest possible number here on this end. Remember, the smallest this could be 0, because distance smallest you could be 0 if you don't move. Is 0 bigger than or equal to negative 2? Well, 0 is bigger than negative 2 all. So it's always going to be 0 is going to be always bigger than a negative number. So the absolute value of any real number is always non-negative, meaning this side is always going to be non-negative. So the absolute value of x bigger than or equal to -2 is always true for all real values of x. It doesn't matter what x value you pick, this is always going to be bigger than the negative number here. And therefore the solution is all real numbers of x. That is, x can be any number. Let's look at an actual example. So let's say we want to solve this inequality for x. Now notice here you have a +6, but then the absolute value is not isolated. So let's go ahead and isolate the absolute value by dividing both sides by -2. And remember this, when you divide or multiply by a negative number, this symbol is going to reverse. So you get the absolute value of 5x minus 3, it becomes less than -3. Well, because I have a negative number here, I have to analyze this, right? That is, compare the smallest possible number on this end with this. Well, 0 is less than -3. That is not true. And therefore, this has no solution, right? Because it suggests that the absolute value of 5x minus 3 must be less than -3. Well, we just say that the absolute value of a number is always the distance that number is away from 0. So this cannot be negative. Since this is a non-negative number cannot be less than a negative number. And therefore, this has no solution in this case. Whereas, example 7, we have the absolute value of 2x minus 1 is greater than or equal to -4. Well, problem is that we have a negative number here, so case 1 or case 2 doesn't work in this case. So that means we're going to compare the smallest possible number this could be with this number. And we know that the smallest this could be is 0. Is 0 greater than or equal to -4? Well, 0 is always bigger than those negative numbers. So that's always true. So the absolute value of any expression is always non-negative. That is, it's bigger than or equal to 0, which means that absolute value of 2x minus 1 is always going to be bigger than or equal to 0. So it will always be greater than this negative number right here. So what does that mean in terms of solution? Well, in terms of solution, that x can take any number. It doesn't matter what x value you plug into this variable. This side is always going to be positive, right? Which means it's going to be always bigger than this number. That makes the solution all real values. In other words, the way to write that interval notation would be from -infinity to infinity. That is, it could be any number on a number line. And that would be the end of the lecture for this.